Hello coders, in this video we are going to see some advanced usage of functions in Go. So in an earlier video I had explained what functions are, how functions work. In this video we will see how functions can act as variables as well as functions returning functions, right? So let's get to it. We'll create an advanced.go functions.go. We have our main package, function main, our formatting library, import fmt. Let's write a basic function. Let's say for now we'll have add, which takes in two parameters, a int and b int, which will return an integer result after adding numbers a and b. So the function will be return a plus b, right? Now let's try and print it. Println output, and output is colon equal to add 1 comma 2. 1 comma 2. Let's run the program, right? Now we know what the output is gonna be. It's gonna be 3. Now let's say you had 10 numbers to add, 1, 2, 3. Let's say the first 10 numbers, or let's say 10 random numbers. In that case, what you will have to do is you will have to do something like c int, d int, right? You need to have all the parameters passed into a function, and whenever you have a function, you need to pass in all the parameters inside the function for that function to work. In this case, when we have, let's say 10, 15, maybe we don't know the number of arguments that a function will take. In that case, in Go, there is something called as variadic parameters or variadic functions, where we can have a random number of parameters given inside the function. So the syntax for it would be something like dot 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 int. Now what this dot 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 means is that the add function can accept any number of integer inputs, right? Now let's try to run this program again. Oh, before that, you see I have renamed the parameter name as num. Now what this becomes is an array. Now numbers, maybe I'll name it nums. Numbers is an array. Now what is an array? As I explained in one of my previous videos, array is a collection of similar data types. Right now, since I have named the argument as nums and it is a list of integers, I need to calculate the sum by adding each of the item in the list. Now, how do I traverse the list? I have explained in one of my previous videos. Please do go check that out. So to traverse, first I'll initialize the sum as 0. And to traverse, I'm using the for loop with the range keyword for underscore num colon equal to range of numbers. So range will iterate over my nums list, and num will be the each element in the iteration. I will add this number to the sum, right? And return the calculated sum. Let's go ahead and run this program. Yeah, you see the output is 3. Now, if I want to add, let's say 1, 2, 3, 4, right? I don't have to change anything with my function add. It is already dynamic. It will accept any number of parameters. Now, let's say I don't give any parameters, right? Even in that case, your function will work. The number of parameters for this add function is now optional, and it can take any number of parameters. So this was variadic function with arbitrary number of inputs. Now let's look at a different kind of a function, right? Let's try function, maybe subtract a int and b int, which will return an integer, return a minus b. Right now we have a function subtract which will subtract b from a. Now this is basically a normal function. Let's try to modify its syntax something like this. Equal to function. Maybe I can copy this. Yeah. If you see here, this is also valid in Go, where you can assign an entire function to a variable, and this variable now will act as function. let's try and run this. Subtract, let's subtract 2 from 5. Go ahead and run this. You see the output is 3. We are able to call the subtract function. Now, what is the difference between defining a function like this and in the variable format? It is recommended that we always define function with the name and the keyword func instead of assign it to a variable. This is not a clean practice. It's just that since functions are also treated as first class citizens in Go. What do I mean by that is I can assign that to a variable, right? That is the reason we have a function being assigned to a variable. Now, one more quirk of this program is, let's say where subtract equal to, I have defined this, right? In the program going forward, what I can do is subtract, since it's a variable, I can reassign it with any matching type of the same subtract function. What I mean by that is, now let's say I change this, which takes in same parameters. It is not necessary, so I'll take B maybe now, and let's say F int, and it will return an integer. So that is basically your type. A type or signature of a function is the arguments and the return type. Now here we have the same number of arguments, 2 integers, and the same return argument, that is an integer. And this function, what I'll do is I will return, let's say 0 always, so that we can understand the difference. And now let's calculate the output, right? I will not change the parameters so that it's clear. I'll clear the screen and run the function again. See here what happens is the subtract function, first it returns 3, and that's because this is the subtract function that's being called. We are modifying the subtract variable with a new function which always returns 0. And we are calling the same subtract function. What happens in this case is your subtract variable has been overwritten with this new function which returns 0, and you are getting a wrong output. So that is the reason we don't promote, or we don't encourage to write functions as assigned to variables. So that's the difference when you try to write functions as variables. Let's try this out, right? We will try to modify the add function in such a way that it also takes the same output. We'll take n for now, and it will take integer. It will give back an integer, and let's say it is also returning 1. What happens in this case is this is invalid. You will not be able to compile your program, or you will not be able to run your program. You should get a compile time error. See, cannot assign to add. That's because add is a function. It's not assigned to a variable. So that is the difference between a normal function declared as a or defined as a variable, right? Now, this was all the functions that we saw till now were returning basic types, for example, integer or strings. Now in Go, we can also return functions. As I mentioned, since function can be assigned to variables, they can also return functions. Now let's say I have a function multiply two numbers basically. So a int, and instead of taking the new parameter, what I'll do is this multiply will return your function which will again accept one more parameter for your multiply operation. So that is function b, function int basically, and it will return an int. So now what this statement means here is your multiply function will take an integer and return a function which will take an integer and return an integer as output. So in code, what it means is what you will do is a return. You will have to return the same type as mentioned here. That is function b int, and it will return an integer int, right? So this will be your syntax where multiply is also returning a function. Now how this will work is, let's say I can remove this out for now. What I'll do is I will call the function multiply with a value 10, let's say. Now what your output will have is that this will also behave as a function. This will behave to something like this, where your output variable is now assigned with the value returned by multiply, and multiply is returning a function. Now, to actually calculate the multiplication of a and b, what you have to do is just do return a and b, a into b. Now, if you see here in this particular function, this is the function scope, right? And a is outside the function scope, but it is still able to access a from outside of its function. This particular concept is called as closures. So Go also supports closures just like JavaScript, where you're able to access a variable outside of its scope. Right now, let's try and run this. When you run this, println output. So the output is gonna be a little bit weird. I'll explain why. Yeah, you see, there's an address because your output is actually a function. So you have not actually calculated the output yet. To multiply, what you have to do is, since it's returning a function, product is equal to output of, that is, you're calling that function again. Whatever multiply is returning this particular function. Now it is stored in output and we're calling that function again, and we'll pass the parameters 2. Now this will be your B. 10 was your A, 2 is your B, and let's try and print it out. Product. All right. Now you see the output is 20. That's what we expected. So instead of calling it in 2 lines, we can also do something like output is multiplied 10. And since we know that it is going to return a function, we can chain the functions here. You can chain the function calls here. So multiply of 10, this will be evaluated first, which will have a function returned, that is this function here. And then you will have this function called with b as your parameter. So in this case, your output will still remain the same. Yeah, right, 20. So you can have any number of functions returned. It is not necessary that you have to return a single function. Just like I mentioned in one of my previous videos, Go supports multiple return types. So you can return multiple return values also here. So you can return multiple return functions as well. Now, since we have seen a function returning a function, right? Now let's see an example where a function takes in a function as one of its parameters. So for that example, what I'll do is I'll remove this and have basic functions like function add, which takes in, 2 parameters and returns a sum of a and b. And we can have function subtract, which will also take in 2 parameters. Now, if you see here in this syntax, I have grouped 2 variables, that is a and b. So what it means here is when we have 2 or more variables of the same type, we can group it in this fashion. Here, this is same as writing a int and b int. And then we have return a minus b. Okay. And now what I'll do is I will try and write a function which is generic. So what I'll do is I'll write a function which is called as operate, which will take in 2 integers a and b, and it will also take a function which takes in 2 parameters and gives the output. So for now, I'll write function which takes in 2 integers and returns a parameter, right? And the operate function will return the output of this particular operation. Now, if you see this signature of the function, it is returning an integer. So your operate can also return an integer, right? Now, what we'll do is we know that this function will be performing your operation on A and B. So we'll call that function. To call the function, we have to name it. So for now, we will call this operation. So the operate function takes in 3 parameters, 2 integers, and the operation to perform on it. So the operation will be a function. In this case, what you can do is output is colon equal to, what is the output? The output is the operation on A and B. So we can do operation of A and B, right? What this operation will be defined by the caller. That means anyone who's calling the operate function will tell what has to be done with A and B, and we can return the output, right? Now let's try and use this function now. Let's see, output is colon equal to, I want to operate 2 and 3, and the operation that has to be performed on 2 and 3 is add. Let's say I can send add. So when I just send the name of a function without calling it, that means it's a reference. The function itself will not be called, but a reference of that particular function will be sent to operate. What that means is, when I send add here, this particular operate function, this operation parameter will have the value of the add function. That is this entire block. Now, when I try to run this program, what happens is A will have 2, B will have 3, and the operation will have add. So in essence, the output will be, for this case, it will be same as add 2, 3. Let's see the output. Oh, sorry, FMT imported not used. I forgot to print. Just like variables, libraries also have to be used. They cannot be just be imported and left alone. They have to be used. Println output. Let's go ahead and run this. Leave the screen. Advanced.go. You see the output is 5. Now let's see what happens when I try to change the operation. Now I'll change this to subtract and print the output, because the next time we are calling operate, we are calling with subtract. Now what we'll do is, let's take a function multiply, which takes in 2 parameters and does not give any output, right? So the signature of these two are different. The parameters here is a, b, int, and the return type is int. Here the parameter is a, b, int, and there is no return type. Let's say we'll directly output the result, a into b. Now this is a valid function, right? But let's see what happens when I try to pass multiply as part of operate. Let's run the program. Here if you see, you get an error, cannot use multiply. Value of function a, b, int as function int, int, int. That's because if you see, the signature of this function is not matching with the signature of this function because of the return type. Right now, for this to work, what I have to do is I have to change that type so that multiply will return an int and it will return a into b. Let's try and run this. Yeah, you see 5 and you get the multiplication output 2 into 3, 6. So that is how you can pass functions as parameters to other functions, right? So that was all about functions, closures, and advanced usage of functions in Go. On that note, this is Concoder signing off. Catch you in the next one.